and welcome to Tech to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KaiZen's own Will Sweet.
Thanks, William. And thank you, everyone, for attending what will be a pretty short talk on a case study on an application fix that I was involved with a few years ago. I have it titled Finding the Right Solution, and that will make more sense as we get through the presentation. This is all done in an aqueous cabinet spray washer, and we're cleaning cast iron parts throughout this whole application. The opportunity. This is for a large oil and gas industry supplier. So they're supplying parts to the actual oil and gas industry. These are large cast iron compressor parts. And if you'll see on the picture on the left, these parts are actually eventually assembled into oil and gas pipelines. They agreed to cleaning trials with us to help improve their cleaning process because they were using a different chemical supplier before they brought us in. The challenge to provide an effective cleaning chemistry to enhance the current cleaning process. Again, a different chemical supplier than us. The idea is to remove a solvent-based RP from the parts. These parts have the RP on them as they receive them. The goal is to remove this RP so that it can move on to paint afterwards, and the paint will successfully adhere to the part. We want to provide a solution for hard to reach areas. These are large compressor parts, almost like large thick tubes. And for a cabinet spray washer, it's really hard to get down into a part like that, into the middle of that. So that's what we're looking at, improving cleaning efficacy enough to where even though there's a slight lack of impingement in that area, we can still clean it. The maximum corrosion protection that they will need, worst case, is up to 2 days. Really, they only need enough time to get from the washer to the paint line, which usually is 30 minutes or an hour. But again, worst case, they need 2 days of protection. And there's a large emphasis on technical support here as well. They felt like their current chemical supplier was not giving them enough help or helping them solve these issues that we're talking about right now. So that was really what got us in the door. Us willing to help and really see if we can get in there and do some of the dirty work for them and help figure out their process. And their current cleaning process before we got in there, and I mean, still now too, but they have 17 large cabinet spray washers facility wide. And you'll see in the pictures down here below, most of them look very similar to this. They all have between 500 and 1,000 gallon liquid capacity inside them. Top and side spray bars. So you'll see on the picture on the right, you see one coming down over there, but on that same spray manifold going down the side of the machine is also some more spray bars or some spray nozzles. There's also a rotary table platform at the bottom there that actually spins so that the spray bars can reach all sides of the part while it's in there. The competing aqueous chemical that they were using was considered a mild alkaline solution. Its working pH was around 9 to 10 pH, and that's just good to know moving forward. So the process parameters for the competitor product that they were using is 150 degrees Fahrenheit, between 6 and 7% concentration, the range that they're working with. Spray and hair, obviously, in the cabinet spray washer. The wash was 5 minutes long. There is no rinse, and there was a forced air blow off, so there really is no dry section either. It's just blown off with ambient air. And then for our cleaning trial, we decided to stick as closely as we can to their regular process parameter, so 150 degrees Fahrenheit. We chose the Metalnox M6324R, which is a pretty high alkaline product, so a pretty aggressive cleaner. We went at the low end of the range that they have been working with, so 6% concentration. Obviously, spray and air, 5 minutes of wash, no rinse, and then a forced air blow off here as well. The initial trial, kind of what I was alluding to, we wanted to go with an apples to apples approach. So we're just looking. The only change we're looking at is the chemical. So chemical versus chemical. And with this high alkaline product of a working pH around 12.5, it actually ended up cleaning too well. Which I know anybody involved with the cleaning industry, they may have ran into this before, but we cleaned much more efficiently than the other product, and flash rusting occurred within less than a minute after processing. So we were literally able to stand there and watch the rust develop. Interesting sight. but not what we're looking for. So still, they were kind enough to let us try again after this because we're there at their plant trying to help them solve this problem. So we went with another product. The goal here is actually to clean slightly worse and potentially leave a little bit of residue behind to protect from corrosion. So again, 150 degrees Fahrenheit. This time we went with the Menalox M6319NA. We also was still low end of the range concentration they were working with, so 6% concentration, spray in air, 5 minutes, and a forced air blow off. So trial round two. With these trials being treated as a partnership, kind of what we're doing with them, they were kind enough to allow us to try the second product. And the 6319NA is slightly less alkaline, and it's right at a 12 pH. So it's moving from a 12.5 to a 12. And this product also leaves slightly more residue behind. It does not rinse as freely. So with the 6324R, which is very freely, there's very little chemical left behind, and there is slight chemical left behind with the 6319NA. As you guys know, and as I've alluded to, cast iron is very susceptible to rust. So we needed to find a happy medium. So again, slightly worse cleaner with slightly more residue left behind. And then as you can see on the left, the picture, with this more residue being left behind, we wanted to make sure that paint adhesion would still not be an issue. And as you can see, it is not. So we painted half of a part that went through the washer, and all areas of that part of the part had no paint adhesion issues. So we were able to clean the part well enough and still have paint adhere and also avoid any flash rusting before the part got to paint. So the solution, the M6319NA cleaned the cast iron parts very well, but left enough residue behind to protect the parts until they got to paint. This new chemical cleaned the hard to reach areas without impingement assistance. Like I mentioned earlier, the spray bars can't really get down into the middle of those compressor parts in the cabinet spray washer. So having enough cleaning improvement here was allowed to, they were able to clean those hard to reach areas as well. The process parameters did not need to change. In fact, they have the freedom to try to optimize and decrease the concentration even further if they would like. Overall, cleaning and protection has improved. No paint adhesion issues whatsoever, and dedication to technical support was proved. They were very happy with us, even after technically failing the first round, still willing to stick around and try to figure out another solution. So we were able to prove that. Then the conclusion. The customer now uses the Menalox M6319NA in 4 of their 17 washers, while the rest should be qualified by the end of next year. They considered the trial to be a success because it improved cleaning, less chemistry was used. Keep in mind that 1% of concentration still goes a long way in 17 huge washers. I mean, 500 to 1,000 gallon capacity, especially over the course of the year. And they're running these washers at least 2 shifts a day. So it's that definitely adds up, that 1% of concentration. Sufficient rust protection was provided. Again, they really only need 30 minutes or an hour, worst case 2 days, and the 6319NA gets them there. And then reliable technical support. I've mentioned this a few times now, but us being there in the face of potential disappointment and still working to help them find a solution really went a long way with them. So moving on to the FAQs here, what other issues can a chemical change fix by itself? And there are several forces or several variables when it comes to cleaning. I mean, the machine itself, temperature, stuff like that. But just changing the chemical itself can fix a few things too. So say foaming, for instance, you can go out and change to a low temperature chemical, and those are designed to not foam even if there's no heat involved in the wash. So that's one issue you can fix with a chemical change. Another one is corrosion protection. There are a lot of products out there that are cleaner and corrosion protecting combinations. We sell a few of those too, and that is not the 6319NA. That's not what it's designed to do. It just happens to fit this situation that we talked about. leaving a little residue behind. But there are products that are actually designed to clean and then long-term protect a part. So that's another way you can fix with a chemical change. Why wasn't a product with high levels of protection used? Similar to what I just mentioned, I guess. And that was because we were more worried about paint adhesion. That was the number one. As long as we're able to clean well enough, they need to make sure that they can successfully paint each part. And using an actual corrosion protector would there would be too much of a barrier. So there would be some adhesion issues, and really that's why we're cleaning off the solvent-based RP. The one soil we're cleaning off these parts is because you can't paint over that CP. And finally, what if we don't have the bandwidth to allow one or several cleaning trials in our plant? And I would speak to your chemical supplier if that's the case, or maybe even your washer supplier. A lot of them have labs or showrooms or ways to actually test clean parts. And us, I mean, we have a world-class analytical and application laboratory. So we can run cleaning trials in-house, and we can mock up different ways to really imitate other people's cleaning applications. And that is one way you can get some testing done without having to take down production or use it in your own facility. And with that, I will pass it back over to William.
Thank you, Will. Thank you guys for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com, fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.